A variety of permanent waves are available in salons today. Our learning objective is to explain the difference between an alkaline wave and a true acid wave. Alkaline waves, also known as cold waves, were developed in 1941. They have a pH between 9.0 and 9.6. Ammonium thioglycolate is the reducing agent, and it processes at room temperature, without the addition of heat. Curls formed with alkaline waves can be soft or firm, depending on the strength of the solution and the processing time. Acid waves, also known as low pH waves, have a pH between 6.5 and 7.0. Glyceryl monothioglycolate is the primary reducing agent in this type of permanent wave. Although the low pH may seem ideal, repeated exposure to GMTG is known to cause allergic reactions and skin sensitivities for both clients and stylists. True acid waves have three separate components: the waving solution, an activator, and a neutralizer. The activator contains GMTG, which must be added to the solution prior to the application. True acid waves have a pH between 4.5 and 7.0, and require an outside heat source to process. True acid waves do not produce as firm of curls as alkaline waves. In order to produce a firmer curl, and process at room temperature, acid waves have steadily improved over the years. Most acid waves found in the salons today have a pH between 7.8 and 8.2. Modern acid waves are actually acid-balanced waves. Because of the slightly higher pH, acid-balanced waves process at room temperature, and do not require an outside heat source. An endothermic reaction is one that absorbs heat from its surroundings. Endothermic waves will not process properly at room temperature. Endothermic must have an outside heat source, usually a hooded dryer. I remember this bit of information using word association. Endo means enda. Endothermic waves must go enda dryer. An exothermic reaction is one that creates its own heat source. All exothermic waves have three components: permanent waving solution, an activator, and a neutralizer. The permanent waving solution contains thio, and the activator contains an oxidizing agent that must be added prior to the application. Mixing the oxidizer with the permanent waving solution creates a rapid release of heat and an increase in the temperature of the solution. This increased solution temperature shortens the processing time. Ammonia-free waves are perms that use an ingredient that does not evaporate as readily as ammonia, so there is very little odor. Aminomethylpropanol, or AMP, and mononolamine, or MEA, are examples of alkanolamines used as substitution for ammonia. Even though these solutions may not smell as strong as ammonia, they can still be every bit as alkaline, and just as damaging. Ammonia-free does not mean damage-free. Thio-free waves use an ingredient other than ATG, such as cysteamine or mercaptamine, as reducing agents. Even though these thio substitutes are not technically ATG, they are still thio compounds. Thio-free waves can be just as damaging as thio waves. Low pH waves use sulfates, sulfites, and bisulfites as alternatives to ATG. They work at a low pH. These permanent waves have never been very popular, as they are very weak, and do not produce as firm a curl, especially on resistant hair. Low pH waves are generally marketed as body waves,